In Unit 7, we're going to be talking about series. Now, a series is actually just a series of numbers, a sequence of numbers like 1, 2, 3, 4, 5, and you do something to a number in order to get the next number in the series. Today, we're going to be focusing on geometric series. Now, a geometric series is just a series that you use multiplication to find the next number in the series. So, if you look here at example 1, we have this series right here. And we want to know first off what our common ratio r is. Now when I say the common ratio r, what I mean is what number am I multiplying by each time. So to figure that out, sometimes we can figure it out just by looking. 1.2 times what equals 3.6. If it's something that you can figure out on your own, then that's great. But if you can't see it, well, I know that I took my number 1.2, I multiplied it by whatever that common ratio r is, and I got the answer 3.6. So if I solve this equation, all I have to do is divide on both sides by 1.2. So if I type into my calculator 3.6 divided by 1.2, I get that r equals 3. Which tells me that as I travel down this sequence, each time I'm just multiplying by 3. So once I know that, I've been asked to find a sub 5, a sub 6, and a sub 7. Now when I say a sub 5, what I mean is the fifth number in this series. So we know that the first number is 1.2, the second number was 3.6, the third number was 10.8, and so on. And I know that all I'm doing is multiplying by 3 each time. So, to find the next term in the sequence, I'm just going to take the last term, which was the 32.4, and multiply it by my common ratio, which was 3. Oh, sorry, that's going to give me a sub 5. And if I multiply this out, my calculator says that it equals 97.2. So there's a sub 5. To get a sub 6, the sixth number in the series, I'm going to do this in a different color, sorry. There we go. To get a sub 6, the sixth number of the series, we take our previous number, which was 97.2, and we multiply it by 3. If I type that into my calculator, I get 291.6. And then the last number they asked about was a sub 7. To get a sub 7, we do the same thing. We take our previous number, which was 291.6, and we multiply it by our common ratio, which is 3. If I type that into my calculator, I get 874.8. Now, this means that you are going to want to use a calculator for this assignment, and if you don't have a calculator, you should be able to either download one on your phone, or you can also just type straight into Google, and Google will serve as a calculator for you. So that's our first sample problem. Let's go ahead and move on to the back side of our guided notes page. And here on the back side, it asks us for the specified term given the first term and the common ratio. So we know that our first term is 128 and our common ratio is 1/2. We want to know the eighth term of this sequence. So there are several ways to do this, and one of the easiest is to just go ahead and multiply it out. So I know that a sub 1 is 128. Whoops. Not sure how I got a spare 1 in there. Okay, well once I know that, to get a sub 2, all I have to do is take my previous number, 128, and multiply it by 1/2. If I type that into my calculator tells me that it equals 64. To get a sub 3, we take our previous number, which was 64, multiply that by 1/2. If I type that into my calculator tells me that it equals 32. A sub 4 will follow a similar process. We take our previous number 32, we times it by 1/2, and we get 16. And we can just continue this until we get to 8. So for a sub 5, if I have 16, I get 8. A sub 6, half of 8 is 4. A sub 7, half of 4 is 2. And a sub 8, the one we're looking for, half of 2 is 1. And so that is the term that they asked about. Now, that's not too bad if we only have to go to, say, term 8, but sometimes we have to go even further, and we don't really want to have to make one of these tables if we need to find, say, the 100th term, because we don't really want to have to take it out that far. Now, example 3 is asking us for the recursive formula, but we don't actually use the recursive formula on the assignment, so we're going to go ahead and just skip example 3. Let's look down here at example 4. On example 4, it says, given the geometric sequence that follows, write the explicit formula and find the 9th term. So to write the explicit formula, you first have to know the explicit formula for a geometric series is this: a sub n, meaning the nth term of the series, whichever number it is we're looking for, is equal to a sub 1, the first term of the series, times r, our common ratio, or the number we're multiplying by each time, to the n minus 1 power. In this formula, a sub 1, remember, is the first number in your series, and r is the number that you multiply by each time. So the first thing we need to do then is figure out what that r is. Now remember, to figure that out, I start with my first number, which is 32,768. I know that I'm taking that number, multiplying it by r, whatever that common ratio is, and it's going to equal the next number in my series, which is 8,192. Now to solve this equation for r, all I have to do is divide on both sides by 32,768. So if I type this into my calculator, I have 8,192 divided by 32,768, and my calculator says that it equals 0.25, which is my common ratio. Now, it doesn't matter if you write it as a decimal or if you write it as a fraction 1/4. You can write it in either form. But once we know that, we're all ready to write out our equation. So our explicit equation is a sub n equals a sub 1, which is that first number, 32,768, times our common ratio, which was 1/4, to the n minus 1 power. And I'm just going to go ahead and scoot this over so that I have some space to finish this problem. There we go. Sorry about that. All right, well, once I know that, now I'm ready to go ahead and find the 9th term that they specifically asked about. So I'm going to be using a sub 9 because it's the 9th term I'm looking for. That will equal my 32,768 times 1/4 to the 9 minus 1 power. And now all I have to do is type that into my calculator. So I have 32,768 times 1/4 to the 9 minus 1 power. And my calculator says that that equals 1/2. So this is my 9th term, and this is my explicit formula. Once I know that, let's go ahead and look at example 5, which is a story problem. Here on example 5, you're planning to experiment on a certain bacteria strain. It takes 1 hour for a cell of the strain to double. If you begin the experiment with 64 cells, how many cells will the experiment have exactly 1 day later? Well, first we're going to write out the explicit equation. So I know that a sub 1, the amount I had at the beginning, was 64 cells. And in this case, they told me that R, my common ratio, is that this strain is doubling. So I'm going to be multiplying by 2 each time because I'm going to be doubling. Okay, so that means my explicit equation is A sub n equals my initial amount 64 times the number I'm multiplying by each time 2 to the n minus 1 power. All right, well, once I know that, now I'm ready to figure out how many cells I'm going to have one day later. Now notice that we double every hour the number of cells that we have. So since it doubles every hour, if I want to know about one day later, I need to know how many hours that is. Well, there are 24 hours in a day. So if I want to know how many cells I'm going to have in a day, that's going to be 24 hours. So I'm going to find A sub 24 because I want to know 24 hours later. That's going to equal 64 times 2 to the 24 minus 1 power. If I type this into my calculator tells me that it equals this somewhat large number, 536870912. So that's how many cells I'm going to have at the end of this 24-hour period. Once you have this figured out, go ahead and try out your assignment and see if you can get it. When you've finished the assignment, head over to the discussion board where I've posted the answer key, and you can check your work and make sure it's correct before you submit your assignment.